Hello everyone. Today we are going to learn to plot the moisture content and the dry density and to find out the optimum moisture content. This is a question from B.M. Das and Khalid Soban's Principle of Geotechnical Engineering. So in this question, the laboratory test results for a standard Proctor test is given in the following table, and we have to find out the dry unit weight, gamma D of the compaction and optimum moisture content, and also the gamma D dry density versus moisture content for degree of saturation 80, 90 and 100%. So this is the question, and to find the optimum moisture content we have to plot dry density versus moisture content. So moisture unit weight and dry unit weight have to be calculated first. The formula for moisture unit weight is given here. It's gamma is equal to weight per unit Vm, that is weight of the soil by volume of the mold. So we're gonna do equal to weight of the soil divided by volume of the mold, and we have to bring it in the unit kilonewton per meter cube. So it's gonna be 1000 times. Likewise, we can drag this to get all the values for the moisture unit weight here. And for dry unit weight, we have this formula: dry unit weight is equal to moisture unit weight by 1 plus moisture content. So it's going to be 1 plus .01, because it is in the percent. So we get the dry unit weight 16, and likewise we find the dry unit weight for all the values. And now we have the required value. These two are the values that we had to calculate. After that, we have to find out the dry density versus moisture content for degree of saturation. S is equal to 80, 90 and 100%. For that, we need the formula for given degree of saturation. In order to find out the dry density, we have to use this formula here. Gamma D, that is dry density, is equal to G gamma W by 1 plus WGS by S, where S is the degree of saturation and gamma W is the unit weight of water. And so here for 80% saturation, we have to use this formula. Is equal to, we have the value of G is 2.7 and we have those moisture content. G is equal to G times gamma W, which is 9.81 divided by 1 plus the moisture content is 8 times the specific gravity divided by S, which is 80%. So since both moisture content and degree of saturation are in percent, we don't have to change anything here. We can directly write 80. And to be extra sure, let me add another bracket here. So we have 20.885 So we can drag it here. For degree of saturation 90, it's the same. Okay. It's 2.7 times 9.81 divided by bracket 1 plus moisture content moisture content times GS, that is 2.7 divided by 90 and for degree of saturation equal to 100%, we can do the same. G times 9.81 divided by 1 plus G times W, that's 8 divided by 100. So now we have all the required values, and all that is left for us is to plot it into the graph. So we have to go to the insert, to the scatter plot, and scatter with smooth lines and markers. Right click, select data, add series name moisture content versus dry density for series X value. In the x-axis we're gonna plot the moisture content, in the y it's gonna be dry density. Okay, add so we get this kind of value here. We have to add for S is equal to 80%, X value still moisture content, and for y value it is this column. Add S is equal to 90%, S is equal to 100%. X value is the same moisture content, Y value is okay. It's the dry unit weight or dry density, kilonewton per meter cube. Moisture content. More options. It's in the range of 0 to 25, so let's change the range from 14 to 20. Okay, 14 to 22. Let's say 10. Okay, and for moisture content, the bound is, let's put it 5 to 21. Okay, so this is our chart title. It's the dry unit weight versus moisture content. Let us include trend line also. So this blue line is the moisture content versus dry density, and this is saturation line for 80% saturation. This is S is equal to 90 in gray color, and likewise So to find out the optimum moisture content and the dry unit weight, maximum dry unit weight, we have to see the maximum value in this curve and plot it straight to the both axes. So for this, let's go to insert, shapes, and a line. So the highest point in this curve is this. So let's plot it straight down here. And straight to this point. So this becomes approximately 14 and the moisture content comes in the range of 14 and the dry unit weight will be in the range of 17. So from the book of PM Das, the OMC optimum moisture content is 14.4%, and from our graph also it's somewhere between 14 range, and dry density or maximum dry unit weight is equal to 17.15 kilonewton per meter cube. And this is our answer, and this is our graph.